supposed to see your face?
What?
Am I supposed to see your face?
Who? Yes, you should be seeing you should be seeing my face right now.
All I see is your profile picture.
You only see my profile picture?
Yeah, like I click on you, but all I can see is like a circle.
Really?
Yes.
Bethany, can you see me normally?
Yes, but sometimes it'll just have a bubble with your name in it, and I have to click it again to see it.
Click it. I
click
clicked
the bubble to show up again.
Okay, Gracie, did that work?
I'm clicking your bubble.
Or pin somebody else, and then try his again.
I pinned yours. Oh, there you are. Okay. I got it.
Well, it's very nice to see the top of your head, Gracie.
I'm doing you a favor.
Okay, so what we want to do today is we want to talk about the second part of the airport problem. You have that in front of you. So the first part was assume you and 6 family members are standing in line trying to get into Guadalajara and go through customs. We want to expand that for the second part to assume that there are 50 people in the queue or in line to go through the customs stoplight, and we want to see what that looks like graphically and also in terms of what can we learn about the distribution and the probability of getting through and things like that. So I don't know. I'm going to try to share this my screen again, and I've had trouble showing the calculator. So I'm going to present, and this time I'm going to present my entire screen, and hopefully you'll be able to see the calculator when I put it up here. Can y'all see the calculator now?
No.
Yes.
What?
I see your whole screen, actually.
You see my whole screen, including the calculator?
Yes.
Yes.
Okay. All right. Well, that's good news then. So let me clear that, and I'm going to leave that up for the most part. So now if I click to this part right here, do y'all see the problem, airport problem number 2? Y'all see that?
Yeah.
Ah, okay. Well, this works like it's supposed to. I don't know why I had so much trouble with it before. Oh, well, we are where we are. Okay. So,
Okay.
So the first part, we wanted to just generate a random number from a binomial distribution, and we have to give it some information. We know that there are 50 people in line, and there's a probability of 0.3 being selected. So that one's pretty straightforward. We're just going to go to math, and then probability, and then choice 7 is picking a number from the binomial distribution, and then the comma is right above 7. So we'll click on there. Have a probability of success of 0.3. If we do that, we get a number. We get number 19. Now, when you all do that, you'll all get a different number. Because this is a randomized process, okay? So, so that's the first part. That's pretty straightforward. Now, the part 8 here, there's really nothing to record, but there's a lot of instructions. And ultimately, what we're going to do is what we just did in step 7. We're going to do that 50 times in a row. We're going to generate 50 samples. And save them into list 1 so that we can do a little bit of graphing and a little bit of data analysis. Okay, so what this says to do is we'll start out with the same parameters before n equals 50, P equals 0.3. But there's an additional parameter you can stick in here, and this last 50 is the number of trials, okay? So if we enter this, it will generate 50 samples from a sample of size of 50, and with a probability of success of 0.3. And then we'll do all of that and divide each one of those by 50 to get the proportion, because that's what we're looking for. We want to compare it to this proportion of 0.3. So we'll just go ahead and divide them by 50. So let's do that first. So we'll go back to math, 7, 50, 0.3, comma 50. Okay, and so we'll take each one of those samples and we'll divide that by 50. And go ahead and hit enter on your calculator now, and you'll take a minute or two to get that done. And you see the first few values that are selected. Use this set of data like it is now. So we're going to store that in list 1. And the way you do that is you click the store button on the bottom left-hand corner right above on, and we can store that in list 1. And so what you'll see on your screen is it take the answer, the little arrow, and store it in list 1, and hit enter. And you see the row of proportions again. But now if we click on the stat button, we edit. In list 1, sure enough, we see those first 4, 0.28, 0.3, 0.22, 0.3, etc. And we can scroll down all the way to the bottom, and there's 50 values in there. So that's all we've done with step 8, is just figure out a way to get 50 samples from or 50 trials from a sample size of 50 and a probability of success of 0.3. That's all we've done in step 8. There's really nothing to record here. It's just really a set of instructions. Now, step 9, we want to do the first thing, always draw a picture. So we'll go back to our data, and we'll turn on stat plots. We'll turn on stat plot 1, hit enter. It's on. So now I'm going to just go over highlight histogram, cursor down, make sure you select list 1 or whatever list you chose to store that in, hit enter. And now we can graph that. And depending on what was in your calculator before, there's no telling what shows up on your screen. On my screen, there's nothing, so I'm going to go zoom. And if you cursor down to 9, that's zoom stat. So that'll bring that graph right into play, right into view. And wow, that looks really, really good. Usually it doesn't look that good. Sometimes we have to manipulate it. That's what I was trying to do the other day, and I struggled a little bit. So let's see. If I hit the trace key, then what I see here is the minimum is 0.4. Maximum, so the right-hand side of that bar is 0.185, and there are 3 values in there. If I go over to the next one, I have 5 values, 8 values. And then the middle one, the tall tent pole, it includes 0.2, say 0.28 to 0.32, which includes this expected value of 0.3. So that's why there are so many of them. But let's just say, for sake of argument, I want to manipulate this graph a little bit. I see the minimum value is 0.14. And so I want to make my bin width a number that makes sense to me. So I'm going to go over here, click on window. The minimum value of 0.14 seems okay. So what I'm going to do, the maximum value is 0.5, a little over 0.5. So I'm going to leave that alone for a minute. And the scale, this is what I'm going to change. I'm going to make this, I'm just going to make it 0.04. And see what that looks like. And then when I hit graph, the shape of the graph has changed a little bit, but notice when I trace, my max and min values are a little bit more consistent. And so that graph looks a little better. I don't know, maybe it doesn't look a little better. If you want to go back to the original one, you can just hit zoom stat and it'll take you back to the original picture. Okay, so I'll use this one just because it's easier to talk about bins that are a consistent bin width. And we'll go back to this and say, okay, now I want to draw the histogram. Well, the histogram, I gave you some graph there. You can really, what I want you to do is just kind of duplicate this graph with a sketch here. It doesn't have to be picture perfect. You know, we're not necessarily looking for a Rembrandt. A Picasso will do. I need to see the details. I need to see a couple of things. First of all, the values in each bar need to stand out really, really easily. And so if you just want to write on top of the bar, 7, this one would be 13, that one would be 9, etc. And make the widths of the end post of your bars consistent, so that's easy to read. So there's the graph. I just want you to see the shape of the histogram, and by now we should be pretty comfortable saying that this is symmetric. The center is somewhere around between 0.6 and 0.3. I'm sorry, 0.26 and 0.3. And we can even talk about the spread, but in just a minute we're going to calculate mean standard deviation. So not too worried about describing it, but anyway, there it is. And you have the freedom to manipulate your graph until you get it to make sense for you, or you can just use the one that pops up. Either one of those is fine. Questions so far? Everybody with me?
Yes.
Okay.
I'm having a calculator problem.
You're having what?
A calculator problem.
Okay. What is your calculator problem?
I'm trying to change the width of the thingies, and I'm changing it in here on the X scale, but every time I go back to it, it's not changing the actual number. I don't know if I need to hit enter or.
Okay. So you're going down here to X scale and you're typing in 03 and then hitting graph.
Yeah, and it's not changing it.
Yeah, you actually have to hit enter before it will change. It'll change the width. Okay. Anytime you change a value, so now that when I hit trace, you can see mine are 0.03 apart. Okay. So anytime you want to change a value, you have to hit enter, or it will register on your graph.
Okay.
I got a dumb question.
Okay. I don't think there are any dumb questions, but go ahead.
Well, okay, so all of ours aren't supposed to be because we got different numbers. Mine's skewed. That's all right, right? Mine's not supposed to be symmetric like yours, is it?
Well, I would be surprised that it's skewed because we have a pretty large sample size and we took a lot of samples.
Because mine's pretty skewed.
Okay, I tell you what, let's do this. Let's go to the next step and we'll calculate the mean and standard deviation.
Okay.
And we'll look at that and see if that makes a difference. Okay.
Okay. All right.
So here's our graph. There's my graph anyway. Yours will necessarily look different because you got different values. But keep that picture in mind and describe the histogram. That's SECS, shape, extreme center spread. And now we're going to go step 12. We're just going to calculate the mean. We're looking primarily for the mean and standard deviation here. Okay. So we'll go back to our calculator. We'll hit the stat button one time to calculate. And we want to do one variable stat. So we'll select that one. My list is list 1. You may have put yours somewhere else, but cursor down to calculate and hit enter. Here's our value. Okay, X bar, that's the value we're really interested in. And then remember, we get 2 standard deviations. SX is the sample standard and sigma X is the population standard. In this case, we want to use SX because we're taking just a sample of 50 of all the people in the airport or all the people that went through customs. We only looked at 50 of them. So we don't want the population standard value. We want the SX. Now, that's something that might be a little confusing. We will begin to refer to this as sigma X bar. But that have to keep in mind that really is just the sample standard deviation, not the population standard deviation. But honestly, to two significant digits, they're both 0.73. And so it really doesn't matter that much. And in this particular exercise, I'd be surprised if these 2 values are different to 2 significant digits. To 3 significant digits, you know, this one's 0.7 or 0.0734 and 0.02726. So they differ by 8 thousandths. That's really small. So practically speaking, those are essentially the same value. But all I'm going to talk about is 0.73 or 0.073. That's what I would record here. And the reason for that is the probability, the proportion of red is 0.30. That's to 2 significant digits. I don't want to carry out my results any farther than 2 significant digits. So when I look up here at X bar, I'm going to call that 0.30. When I round that up, it's going to be 0.30. If you wanted to be really precise, you could call it 0.298, but that's extending farther than you need to in terms of significant digits. But anyway, 0.298 is okay. 0.30 is okay. Both of those are fine. I do want to scroll down here just so that we can record a couple of values. The minimum value is 0.14. The max value is 0.46. Without scrolling through your whole list, those numbers would be hard to come by. The other value that I want to look at, and Gracie, this will be something that's important for you. The median is 0.29 here, right? And so if a distribution is symmetric, then the median and the mean should be pretty close to each other. Well, 0.29 for the median and 0.30 for the mean, those are pretty close.
Okay, yeah, mine are close. Maybe it's just the way I had.
I think if you toy around with the window,
I got you.
that you'll end up with something that, and I would suggest changing that X scale to a value that makes sense. Here's what I normally do. I go down here and I look at max and min. I subtract those two. So 0.46 minus 0.14, 46 minus 14. What is that? 32. Yeah, 32, and I want to try to divide that up into a reasonable number of bars. Well, if I divide that by 0.04, then I get 8 equally spaced bars. Okay,
Okay.
so that's what that's how I kind of figure out how to make my window. The X scale is I'm looking for equal spacing in the bars. So that's what I would do, Gracie, and see if that helps your graph.
Okay.
If you can't get it to work, then it is what it is. Your numbers are your numbers. So just use them and go with it.
Okay.
Okay. So that's and so the values that we really want to record here are the mean and standard deviation. And of course, the question is, how does the average proportion compare to the 0.30 claimed by the custom officials? And it's dead on. There is no difference practically in my data set. Now, your data set might be a little different. I did this the other day. The standard deviation that I calculated was, again, this one was 0.302. The mean was 0.302 and the standard deviation was 0.073, which is amazingly consistent. So I'd be surprised if you guys get values that are much different than those. We took a large sample size, 50, and we took a lot of samples, 50 samples. And so I would expect our values to be really, really close there. So 13 is where things get really weird. And that's where at the end of class, I was kind of hustling to get through this. And I want us to step through this a little bit more carefully. Okay, so now we're going to say, okay, instead of 50 people, let's see what happens when there are 100 people or 150 or 75 and then finally 25, a smaller group. But we're still going to take 50 samples. We're still going to simulate this 50 times. So we're going to change the values in our random binary statement a little bit. So we're going to go back to math, probability, choice 7 for RandBin. So everybody go there. The first one we're going to do is with 100 passengers. So the first value I'm going to put in is 100. And then comma. Still using a probability of success for the light of 0.3. And I only want 50 values. So 50 is going to be my last value, or yeah, 50 is my last value. And then I'm going to divide again to get a proportion, but I'm going to divide by 100 because the values will vary between 0 and 100. So to convert that to a proportion, I've got to divide by 100. So don't divide by 50, but divide by 100 here. And so I'll hit enter. Calculator will do a little bit of number crunching, and then it'll spit out 50 values. And again, we can see that I did the proportion correctly. I'm getting values pretty close to 0.3. So those are all values that I would expect to see. So now we're going to store those. And this time, I'm going to store it in a different list, just so that I don't overwrite list 1, just in case I need to come back to it. I'm going to store it in list 2. Hit enter. Now I've stored those in list 2, so I can go to stat and edit. And sure enough, list 2 now has the values that I'm looking for. If I hit the up arrow key a couple of times, I scroll over the top, and again, I see I've got 50 values. I still have 50 samples. Okay. It's just that in this case, the samples were taken from a sample of 100 people rather than 50. And if you remember our discussion yesterday, standard deviation of p hat here goes down when sample size goes up. So I expect to see the value for the standard deviation to be smaller than 0.073, which I got last time. So let's see what we get. So we'll go back to the stat and calculate one variable stats. And now instead of list 1, I want to use list 2. And no surprise whatsoever, the mean of p hat here is 0.31. But notice what happened to my standard deviation. It went way, way down. The standard deviation is now 0.09, 0.049. And so sample size goes up and variation goes down, which is exactly what I would expect to see. Okay. So that's really it. That's the essence of this whole exercise. Is I want you to repeat this now with 150, with 75, with 25, and record those values here in this table. Okay. And then the last make a scatter plot of the x-axis where the sample size is on the bottom. So it'll be 25, 50, 75, 100, 150. Now be very, very careful with your spacing. The first few samples we increase by 25 each time, but we go from 100 to 150. Make sure you space that out correctly across the bottom. And then the standard deviation, the values for the standard deviation will go on the vertical axis. So 2 values we've calculated so far. We want values on that y-axis of 0.049 up to 0.073. So that's the kind of the scale that we're looking here. You want to go ahead and complete this table and see what the scale of these values is. So what you should expect is the value, the standard deviation for a sample size of 25 is by far the largest number, and standard deviation for a sample size of 150 is by far the smallest number. So what you should expect to see. Now, is it possible that in here somewhere it doesn't always go in descending order? Yes, it is exactly possible. In fact, when I did mine, there were a couple of numbers that were almost the same, but that's okay. I'm pulling random numbers out of a hat, literally, and so I expect some variation in that. Don't panic, but I wouldn't expect to see a number like, I don't know, 0.08 or 0.09 up here for a sample size of 25 is reasonable. And then come down here to 150 and get 0.07 again. That would be really, really surprising. Okay. So you should get whatever your data tells you, you should get it. Just record it. And then question 16 says, well, let's compare this to the theoretical value. Well, the theoretical value, the only thing that's changing here is n. P is 0.3, 1 minus P is 0.7, so you're going to have 0.21 in the numerator every time. You're just going to divide by a different n. And what I did out here is I came out here to the side and I added another column for this theoretical value. And when I plotted here, I plotted like with dots, I plotted my actual values, and then with an X, I plotted the theoretical value. And the theoretical value should be a very smooth curve. The actual values, you might have some ups and downs in there a little bit. Okay. So, and so now the final question is, do you disbelieve their claim that the value of 0.3 is reasonable? And so you'll look at the data and tell me whether you disbelieve it or not. Okay? Questions? All right. Well, let me turn that off and go back to camera mode here. Okay. So that's what I want to talk about for problem 2. You should have enough now to go ahead and complete that. If you have questions, send them to me in classroom or email or whatever. That's fine. Are there any other questions on any of the other assignments or the questions that we talked about yesterday from the textbook, questions 29 and 30?
I got a
Okay.
question. Did you get my email about? I tried uploading my homework number 1 into that Google Classroom assignment, but
Yeah. Did you do that yesterday?
yes, sir.
Have you tried it again today?
No, I can't.
I know you emailed it to me, right? And so I got it. So you don't have to panic.
Okay.
But I think there was a Google Classroom problem yesterday. I got a lot of emails from students yesterday afternoon and evening saying they couldn't upload it.
Okay.
It may be that we are overloading Google Classroom's capability. And so if that happens again, don't panic. Just try it again a little bit later. And the default is you can always email it to me. I would prefer to receive it on Google Classroom because it makes it easier for me to grade. But if for some reason, if you try a couple of times and you wait an hour and you still can't get it, then go ahead and just email it. That'll be fine. And again, I want to reiterate, I know all of us are on weird schedules. Some of us are working. Some of us are have availability for Wi-Fi at times and don't at other times. So I'm going to be really, really patient with turning stuff in. What bothers me the most is if I don't hear from you. In other words, there are 5 or 6 people in the class that haven't tried to submit anything. They haven't showed up on these hangout sessions. They haven't emailed me, and so those are the ones that are making me nervous about how things are going. So just the main thing is just stay in touch. And if you tell me, hey, Barry, I'm having trouble with this, and my reply will be, okay, how can I help? Take your time. We'll get through it. Okay. I'm not going to zap anybody because you missed a deadline by 36 seconds. Okay. But the main thing is if you see some of the other folks in our class, just remind them, hey, reach out, tell Barry that everything's okay. You're still working on homework. You just haven't had a chance to get it done. And that's fine. Several of my students have contacted me and said, hey, I've been sick. I've been this. I've been that. I get it. That's real life. Just stay in touch. That's the main thing.
Okay.
Okay.
When do you want us to have this like done? Like today?
Yeah, try to finish it today while it's fresh on your mind if you've got the time to do it. If you don't, then let's at least try to get it in by tomorrow. Now, also sitting out there is another set of review questions on AP Classroom. I think it's 5 questions this time, and those are about what we talked about yesterday, sampling, distribution of a sample proportion. And again, they're supposed to be kind of basic level questions to make sure you're understanding the basics. And although they are AP exam level questions, so a basic question on the AP exam is still at least a level 2 out of 3. Sometimes they're level 3. So you'll have to scratch your head. But based on our conversation yesterday, I felt like these should be pretty straightforward for you. And so tomorrow when we get together, that'll be the topic. I'll probably pick out some other questions from the textbook just to kind of go over as examples articles. And if you have questions about what's in AP Classroom, tomorrow's a great time to mention those questions. Okay. All right. Any other questions? All right. Hey, it's good seeing y'all. Please stay in touch. Don't let this weigh you down too much. Get out and get some fresh air. I think I'm going to take the dog for a walk this afternoon and get some fresh air. I think that for all of us. Just stay 6 feet away from everybody. All right. Okay. Unless there are no questions, we'll see you guys again tomorrow. I'll be here at 1 o'clock. If that's not a good time.